elastic potential energy. So remember a spring, okay, can do one of three things. Okay, it can either be stretched, compressed, or bent. Okay, so for example, this is a stretched spring. This is a compressed spring, and this is a bent spring. Okay, so these are the three ways energy can be essentially stored in a spring. So let's visit the formula. So the formula is E equals a half. K is the spring constant, and E is the elastic potential. It's the extension in meters. Okay, so let's say, for example, this is the question. Find the amount of energy stored in a spring with a spring constant of 4.2 and an initial measurement of 3.2 centimeters and a final of 7.9 centimeters. Okay, so remember what we said. E is the extension. Agreed?
Yeah.
So yeah, E is the extension, okay, and K is the constant, the spring constant, and E is a measurement for energy in joules. Okay, and extension is in meters. So straight away we know that there's going to be some conversion involved. So the initial measurement, so when the spring has no pressure on it, this is what it looks like, right? But when you add a weight to it, that's a big weight.
It gets more wider.
Exactly, it gets longer, yeah? Longer. And the distance between here, is essentially wider. So we want to know what the extension is. So how much was it extended? So just for the sake of the image, we'll call this one the 3.2 centimeter, and we'll call this one the 7.9 centimeter. So what's the difference? Well, how do we work out the extension?
Longer.
Yeah, so how do we work that out? How much it got extended? So the extension is
C, right?
Did someone say minus them?
Yeah.
Yeah, exactly. So you do the final minus the initial. So the final is 7.9. Take away 3.2, and the answer is
2.7.
Right, perfect. So the extension, actually I should write it in a lowercase e because we don't want to get confused with the energy. So E is 4.7 centimeters, but what is that in meters? Because that's what the formula requires.
It would be 0.47 meters.
0.047. 0.047 meters. Okay, so that's the extension. The constant is the constant. It's 4.2. 4.2 newton meters. Okay, so the unit for the constant is Newton meters. So we already know that. There's nothing that we can change for that. So we know K equals 4.2. So then we just sub it into the formula again. So E, which is the energy, equals a half times the spring constant times by the extension squared. So if you can just hit that into the calculator and tell me what you get.
I got
I got 4.6389 times 10 to the power of minus 3.
Yeah, same here. So this is a very small spring. Okay, so there's never going to be so much energy stored. So 4.6389 times 10 to the power of minus 3, and the unit is going to be in joules.